Assalamualaikum and good morning, students.
Waalaikumsalam, teacher.
Good morning, teacher.
Good morning, teacher.
Okay, thank you for being punctual today. So, how are you today? Have you taken your breakfast?
I'm fine, teacher. I'm not taking my breakfast yet.
teacher.
I am fine, teacher.
Never mind, later
Not
you can
yet.
eat, okay? Never mind, later. You can eat. Okay, so, I want to start with our lesson today. So, firstly, we are going to learn the new subtopic today, which is 4.2 Law of Set. Last week we already covered 4.1, which is Law of Indices. Okay, so the learning outcome. Student can compare rational numbers and irrational numbers. Second, relating sets with irrational numbers. Okay, firstly, before we jump into our new chapter today, let me ask you, do you still remember about rational number? Because if I'm not mistaken, I think you have learned about this in Form 1, right? Do you remember?
Yes, teacher.
Yes,
Okay.
teacher.
A little bit.
Okay, very good. Can I have a volunteer to explain what is rational and irrational number?
For rational number is a decimal that can be converted into fraction.
Mm-hmm. And then how about irrational number?
Can I try, teacher?
Yes, you can.
Irrational number is a decimal that cannot be converted into the fraction.
Okay, very good. All the answers are correct. So, rational number is the number that can be converted to fractions. Meanwhile, irrational number, the decimals cannot be converted into fractions. Okay, so when we, for example, we have a over b here. So it is said that a and b are integers. B is not equal to 0. So what happens if we have a over 0? It become what?
It will become infinity.
Yes, it will become infinity. Okay. Alright, great. Very good. I see that you still have the little knowledge about the rational and irrational number. So, to see whether you are truly understand, we will have a short quiz. So, firstly, I want you to go to miro.com and complete the table by classifying the number based on their category. So, you may discuss with your friend. I give 3 minutes from now. So, everyone please get into the link that I provided just now.
Okay, teacher.
Alright.
Okay, teacher.
Okay, I can see Hafizah is already here, Nadira Aiza, and also Siti Nor Anisa. So what are you gonna do is, you need to drag the numbers, that is rational number and irrational number. Okay, are you done, students?
Yes.
Okay,
Okay.
very good. I can see there are 4 numbers in the rational numbers and there are 5 numbers in irrational numbers. Okay, so I need you to do some observation here. So, between column 1 and column 2, what are the differences that you can see from the table?
For the irrational number, there is a square root symbol.
Okay, we have square root. Other than that,
For rational number, we have a repeated number.
Okay, we have repeated number. Okay, very good. Okay, so I can see that you can observe the differences, right? So when we talk about square root, so square root must be in the irrational numbers. Why square root cannot be inside the rational number? Can someone answer my question?
Me, teacher. I think it is because square root cannot convert the number into fraction.
Okay, very good. The answer is correct. square root must be inside the irrational number because rational number is the decimal number that can be converted to fractions, but square root we cannot convert it to fractions. For example, if you calculate we calculate square root 2 inside your calculator, what the value that you get?
1.414.
1.414.
To 1, right? So notice that the irrational number, if you solve it, you simplify it, you can get decimals, but is it changed to fraction?
No.
No, right? Okay, so
No.
very good. So I will continue in the slide. So just now you can see the square root inside the irrational number, right? So square root, another word is we call as third. Okay, third. Okay, actually what is third? Okay, I want one volunteer to read in the slide here. Maybe I want to have Hafizah.
Okay, teacher. Sets are numbers in the square root form. Set A, where A is any positive integer. Sets have infinite decimal place and no recurring.
Okay, very good. Sets are number in square root form. Square root A, where A is any positive integer, and sets have infinite decimals, places, and non-recurring. So, do you have any idea on what is non-recurring?
No, teacher.
No. Okay, this is okay because
I am not sure.
okay, never mind. Later we will see the example. Okay, so firstly, in order for you to learn the cert, you need to know how to read cert, how to pronounce the cert correctly. Before that, let me recall again what we have learned last week. So, 4.1 Law of Indices, quick access. We had learned zero index, we had learned negative index, and lastly, we learned about fractional index, right? So, fractional index, we have a to the power of 1 over n. So, 1 over n is indicates like this, right?
Yes.
Is it the same with this?
Yes.
Okay, so we need to know how to pronounce it correctly. So, the way on how to pronounce it, first, inside the radical here, you call it cert A. Meanwhile, on the outer side here is order n. Okay, so how about this one?
Cert A order 3.
Okay, very good. So let's see the answer. Yes, correct. Okay, let's proceed. Okay, are these two expressions give the same value? Is it the same?
No, it's not.
No. Okay, why do you say no?
Because the right one is multiplication.
Multiplication. So how about the left one?
The value of n is value of set.
It is the power, right?
The power.
Okay, so we will see how you would determine the value. So actually, you can test the expressions here by inserting any value inside the expressions. For example, we have n equals to 3 and a equals to 8. Okay, for example, we substitute n equals to 3, a equals to 8. So you get cert 8 or the 3. So if we put it into the calculator, what the value that you get?
2.
Okay, you get 2.
2.
So how about this one?
8.485.
8.485, right? Okay, let's see the answer. Okay, correct, very good. Okay, so next, we need to learn that not all number in radical are sets. So, any number in the radical is actually not sets. Can you believe that? Okay, for example, if we have cert 8 with the order 3, why do you think that I put it into the not set? Why?
Because the number is not in decimal.
Yes, correct, because the number is not in decimal. So how about this one?
I think because the number is end at 5, there is no infinite
Yes,
decimal.
the number is n at 5, which means that it does not have any continuing decimals, in which that it has ending decimals. It does not have unending decimals. Okay, it is quite different with the set here. So, since we have set 8 and multiply with 3, we get the answer 8.485. Why do you think that it is kind of set?
Because they have infinite decimal, continuous decimal number.
Okay, because it continuous. Okay, can you give me some example about set? Any number that can produce the decimals that unending decimals, or it is non-recurring. Non-recurring means it is non-repeated digits. For example, we does not have any repeating digits here, so it is called set. So can you provide me some examples? The number that is set. Yes?
Set of 5.
Set of 5. Very good. So how about number that can represent set that is actually not a set?
Set
16.
Okay, set 16, because set 16 can give the answer is 4, right? So since 16 since set 16 can be simplified into any integer, it is called not set. So basically, what you had learned just now, okay, not all number in radicals are set, because when a number can be simplified by eliminating the root, it cannot be classified as set. That is why we call it not set. Okay, so for example, number with radicals, if the values are integers and recurring decimals full. So number with radicals, for example, we have set 4. So set 4 will produce 2, right? So 2 is integer. Okay, and then set, when a number cannot be simplified by eliminating the root, it can be classified as set. For example, we have set 5. For example, we have set 8 with the multiplication with 3. Okay, so number with radicals if the values are non-recurring decimals. So for example, you can see in this slide, so is the number here is same with the beside the number? It is not same, right? So that is why we call it non-recurring, and it is not repeated. So I want you to do some activity. So I need you to return to the Miro.com and complete the table with decimal places. So I need you to take out your calculator now.
Okay, teacher.
Alright. Okay, please put the value the next with the number. So what you need to do is you find any fraction number or any number with radicals and convert it into decimals. For example, in the rational number, we have 2/3. So I see that Nadira is putting 0.66667. Okay, and then we have Siti Nurhafizah trying to type something on the set 7/9. How about Siti Nor Anisa? Okay, maybe Siti Nor Anisa trying to get the answer for the decimal number 4 pi. So we have the answer for decimal number for 2/3. We already have this decimal number for 7/9. Okay, Siti Nor Anisa is inserting the number 3.1416 for the decimal number for pi. Okay, have you done, students?
Done.
Yes, teacher.
Okay, so right now in the rational number column and the irrational number column, you see that you already solved for the decimal number, right? So please observe what are the differences between the decimal number in the rational number column and the irrational number column. For example, let's say I want to compare 2/3, 0.66667 and 0.8819171037. So what are the differences between these decimals?
For the rational number, the number is repeated. For
Okay.
example, 1666.
Okay, so you see this one is the number is repeating, right? The digit is repeating. So the digit that is repeating is 6, right?
Yes.
Okay, so you say, okay, the first one you say the number of 6 is repeating. So how about irrational number? Is it repeating?
No, it is not repeating.
Yes. Other than is this not repeating, other number here is the same. For example, 8819. It is the same.
No.
No, right? So, what can you conclude from this table about the decimal places?
Different number. Irrational number have different number, but rational number have repeated number.
Okay, very good. That is correct. So basically, rational number is the number that can be converted to fraction and also can be converted to decimals, and the number can have repeating digits. Okay, and for the irrational number, it does not have any repeating digits and it has unending decimals. Can you observe this? Can you see this?
Yes.
Okay, very good. Okay, so I will share again my slide here. So basically, this is what you learned just now from the table. So the rational number can be expressed in the form of fraction, which means that it can be in the form of ending decimals. For example, we have, okay, for example, please take a look at this. Okay, so we have 0.175. Do you think that it has unending decimals?
No.
No,
No, why?
because we can convert it to fraction.
Yes, correct. We can convert it into fraction. For example, we get 7/40. So, after 5, do you see any number?
No.
No,
No,
right?
teacher.
So, we can say that when we learn about rational number does not have any unending decimals, in which that they stops at here. Okay, and then rational number can be in the form of recurring decimals. So what does it mean by recurring? It means that some digits is repeated. For example, 0.33333 equals to 1/3. Okay, as for the irrational number, it cannot be expressed in the form of fractional, and it is also in the form of unending decimals. For example, we have set 2. For example, irrational can be exponent and also pi. Okay, on another way, irrational number also it can be in the form of recurring decimals. Oops, sorry, I missed none here. In the form of non-recurring decimals, in which it has infinite decimal number. So what does it mean by infinite decimal number? Can anyone explain?
The number is continuous and there is no ending.
Yes, correct. The number is continuous and does not have any ending. Okay, so wait. So basically this is what you learned just now from the table. Okay, if you solve 7/9 set here, you will get 0.8819, right? So it is non-recurring decimal because it is continuous and it does not have any ending decimals. Okay, same goes for this one. It has repeating number here, repeating digit, in which that it can be converted into 2/3. So, okay, lastly, we are going to learn how to convert recurring decimals into fractions. So, from your prior knowledge just now, you said that rational number can be converted into fraction, right?
Yes.
So, what do you truly understand about rational number? Decimals can be converted into fraction, right?
Yes.
Yes, okay. So, let's learn a new thing today. Okay, for example, 0.5 you can convert easily into fraction. You get 1/2, right? So, how about 0.676767 ... How can you convert into fraction?
I'm not sure, teacher.
Okay, it's okay because I will teach you now. Okay, firstly, what you need to do is, if you come across with the decimal like here, something that is, you can observe that the number is repeating digit, it has repeating digits, and it has ending decimals. Okay, first, you can let n equals to 0.676767, in which that firstly, you need to let n is the recurring decimals here, and then secondly, you need to multiply with 100. So, can anyone tell me why do you need to multiply with 100? Why cannot 1000 or 10,000 or 5 or 10?
Because the repeated number is 2.
Yes, correct.
6 and 7.
Yes, correct, because the repeated number is 2 digits, which are 6 and 7. So, if you have 3 repeated number, so you must multiply by 1000. Okay.
1000.
So, in this question, you have 2 repeating number here, repeating digits for 6 and 7. So, when you multiply with 100, you will get 100n, and you get 67.676767. So this would be the first equation, and this one is second equation. So how do we want to get the value of n? The only n.
Second equation minus first equation.
Okay, second equation minus with one equation, the first equation. So later you will get 99 n equals to 67. So lastly you get n equals to 67/99. Okay. This is the last session for this topic. So before we end our class, I would like to pick randomly one student to explain, to summarize what we had learned today. So maybe you want volunteer, or I pick any number, any name.
Can I try, teacher?
Yes, you may try.
For the rational number, rational number is decimal number that cannot be converted into fraction, and the denominator cannot be 0.
Yes.
And then for irrational number, it is an infinity decimal expansion with no regularly repeating digit or group of digit.
Okay, correct. 10 stars for you. Okay. So, next, how to pronounce set. Any volunteer?
Me.
Okay, Anisa,
Okay.
proceed.
For the number inside the radical, we call it set. And for the outer number, we call as the order.
Yes. So, how about not all number in radicals are set?
Me teacher.
Okay, Hafiza.
When we simplify the number with radical and we get the value in integer or repeating decimal, we cannot call it set. It is
Okay.
not a set.
Okay, very good. Okay, so all the answer that you provided just now is correct. So let me simplify again and let me summarize again. So just now you already learned on how to obtain the set from the irrational number, because irrational number cannot be expressed in the fractional form. It can have unending decimals. Other than that, it has a non-recurring decimals. So set is one of the irrational number. Okay, that is for the summary for this topic. Okay, before we end our class today, I would like to take our attendance by you guys participate in this activity. So this will be your attendance today. So I want you to log into your Kahoot, and this is the code for the Kahoot activity. Oh sorry, the code is 630. Wait, I put it in the chat box. 630. And so let's wait for a few players. Okay, we have Nisa here. We have Nadira. Okay, so I will start our games now. Okay, all got correct for the first question. So next. Oops. Example of ending decimals. Ending decimals is rational number. Yes, the answer is 1. Ending decimals. Ending decimals is rational number. Pi is not. Pi is irrational number. Later you have to check again your slide, okay? Your notes. Okay, third question. Non-recurring decimals. Irrational number except. Yes, the first answer. Okay, for the fourth question. Okay, how to read this question? Yes, all got correct. Okay, next. All numbers with radicals is set. Is it true or false? Yes, all got correct. I can see that you understand this topic. Okay, set 4 can be simplified as 2. Therefore, set 4 is not set. Yes, all got correct for the true. Okay, I think that will be all for the activity. So we got the third place, Nisa. Second place, Nadira. The first place, Hafizah.
Yay, congrats.
Congratulations to Hafizah. Okay, I think the activity will be the last activity for today's session. Let me conclude this class today. Okay, so as conclusion, today we already learned on how to relate the sets with irrational number. And we learn on how to convert from recurring decimals into fractions. Okay, before we end our class today, I will give you the link for homework in the Google form. I think that will be all for today. Do you have any questions for me before we end our class?
So
So
far not
far
yet,
that's
teacher.
So far not yet.
Okay, not yet. Okay. I think that's all for today. Thank you for participating and thank you for your time.
Thank you, teacher.
Thank you,
Thank you
teacher.
so much. Okay, bye bye.